Welcome to Amber Book's 40 Minutes of Competence. And the question was, which of the following is associated with an architecture firm quality management or QM strategy? And you're to select 4 of the 6. The one that I gave you guys in hold on, I'm having a little trouble. The one that I gave you guys last week just said, just look for what specifically does a firm need to do to assure quality control, quality management, and quality assurance. But I decided to do this, and why I did will be apparent in a little while. So I'm going to do things a little bit differently this week. There's not a whole lot to show you, so you can look at me, or you can just make sure that you're on mute, which you all are. I made it so you were, and you can feel free to not pay attention to your screen and to clean your office or to do your dishes. And this can be kind of more of an audio-centered one. And I'll call you back when it's time to actually look at your screen. That will happen later on. So what we're talking about when we're talking about quality management, well, let's start with the story. There is a doctor, his name's Atul Gawande, and he is a cancer surgeon. And he was doing some surgery on a patient in his torso. And he nicked the man's vena cava. It's a major blood vessel, and the man started to bleed out. He started to bleed out. In fact, he lost 10 times the amount of blood that a normal person would even have because they kept refilling him with blood as he was losing blood. And the reason he was alive, well, actually, to talk about the reason that he lived through this, we're going to go back in time about 75 years to 1935. And there was an airplane called the Flying Fortress. It was much anticipated back then because air travel and especially military air dominance was a new idea. People all over the country kind of knew their airplanes, and people were really looking forward to the introduction of this Boeing's new Flying Fortress. The space had been pretty dominated by Douglas, and people were looking forward to Boeing kind of entering the fray. And people gathered around the airstrip where it was going to be demoed and debuted, and they watched in horror as it took off and its nose pointed into the air, and within about 20 seconds it had stalled and it came back to the ground. Fuel was leaking everywhere, but it was pretty clear that some of the crew might have survived. So onlookers were rushing to the site of the crash to help maybe pull out some crew, but there was fear that there'd be an explosion. There was not, but 2 of the crew died, 2 of the 5, and 3 of them were able to live. And when they were looking at what the heck happened, because this was kind of like a Hindenburg or maybe like a Titanic event, people were very aware of it being this new amazing thing, and then on its first voyage it crashed, and so people were like very aware of what had happened. And they started looking at pilot error, and they started looking at mechanical error, and what they found was that it was actually quite routine. There was something called an elevator lock that adjusted the angle of the pitch of the airplane, and that had, in other airplanes, had typically been done by the crew outboard of the airplane. But in this case, the new plane had it inside the airplane, and everyone maybe thought that it was being done outside, or maybe everyone thought that someone else had done it because there were 5 people on the crew. It wasn't clear whose job it was to unlock the elevator lock so that they could adjust the angle of the plane. And so when they took off, they were unable to adjust the angle of the plane, and they were unable in those few seconds to unlock the elevator lock. And what followed was 100 years almost now, or 90 years or so, of the military in their aircraft and civilian in their aircraft really focusing on a culture of checklists. So you can picture, whether it be manned space flight or aircraft or military aircraft, you can picture the pilot and the co-pilot kind of sitting in the front seat in the cockpit, and the pilot saying, I don't know, I'm making up names, but altimeter, and the co-pilot saying check, and the pilot saying, googly goop, goop, and the co-pilot saying check, and so forth. Because that checklist culture has made air travel as safe as it is. So going forward to Atul's surgery, Atul is not a regular person. He's smarter than the rest of us. And he's a cancer doctor. He's not just a cancer doctor, he's a cancer surgeon. He's not just a cancer surgeon, he's a director of his own cancer research lab. And he's not just that, but he's a guy who went to Stanford undergrad, then became a Rhodes Scholar and went to Oxford, and then went to Harvard for medical school. And oh, by the way, he's a staff writer for The New Yorker, and he's written 4 books. But the one that's most relevant here is a book. He was national advisor to President Clinton for healthcare. He has a degree in public health as well, and he's a public health expert. But anyhow, he's not like the rest of us. And he wrote a book called The Checklist Manifesto, and that's what's relevant here. Because while he's an excellent surgeon, and it's unlikely he would have nicked the vena cava, he was ready to nick the vena cava because he had looked back at the tradition in aircraft, specifically military aircraft, and he had developed a checklist for each of his surgeries, thinking about what could possibly go wrong, and then making sure that he had everything he needed in case something went wrong that was time sensitive. And nicking that blood vessel was very time sensitive. So the reason that patient was able to lose 10 times his normal amount of blood is because they had on hand 10 times as much blood as they would need, plus some extra on top of that. And the reason they had it, it's not that he wouldn't, it's not that he didn't, it's not obscure. It's not that he wouldn't have probably had it even if he hadn't made a checklist, but it's making that checklist that makes people do what they need to do. And it's because he's good, it's because those pilots on the Flying Fortress were good that they need a checklist. It's people who are good that need a checklist. Surely you have driven to work a million times and you know how to drive to work. And if you have kids, you may have dropped them off somewhere a million times as well. But every year there's like 40 kids, including one in my little small hometown about 10 years ago, who is tragically locked in the car. Usually the parent will go to work, forget to go to daycare, and close the door and have the windows closed, and then the child will be trapped in the car and die. And your heart goes out to the family and the child. But I think part of the reason that's especially heartbreaking to many of us is we can kind of picture us doing it. We surely aren't going to leave our kid in the car because we're bad at driving. It's because we're good at driving and we kind of can do it automatically. And so you can imagine a scenario where if every car dinged wildly and had a screeching sound until you hit an OK button, reassuring the car that you don't have a child in the back seat when it's above 80 degrees outside. If you had a button like that on your car, you could imagine that 40 per year would probably, if it was on every car, I'm thinking it would go down close to zero, because not because we don't know there's a kid in the car, but because we're on autopilot. And so that brings us to this idea of quality management. And quality management is the science of doing stuff that's pretty obvious. It's like all this stuff and that's one of the reasons I wanted to just kind of talk to you about it, is the things that are involved in the profession of quality management are kind of common sense, but the idea of quality management is to give those common sense ideas structure, to make them into things like checklists, to make them into things like policy, and to get in the case of an architecture profession, to get firm-wide buy-in into what those things are. So, what does that mean in practice? Well, let's look at our answers to this question. It says, which of the following is associated with an architecture firm quality management strategy? And you're to select 4 of the 6. And the 4 that are the ones that we need, that we should be using, are eliminate waste in processes. That's 1. Treat your consultants as customers. That's 2. Utilize check sheets. That's 3. That won't be surprising to you based on what we just talked about. And utilize scorecards. Track employee time in smaller increments. Not really. Not typically, unless that's a specific issue that your firm is having, that you're tracking it in 2-hour blocks or something like that. But quality management is not about necessarily making more paperwork. In fact, it's very much about eliminating unnecessary paperwork and unnecessary parts of the process, any process, whether it be RFIs or onboarding documents or that kind of thing. So for instance, if your firm has an onboarding packet that they give to new employees and it's 35 pages thick and nobody reads it, maybe the better way to do it is to have a bulleted list, 1 page long, with a link to the other 34 pages or 35 pages that people can click on if they want to learn more about it. It's better to have everyone look at the 1 page and some people look at the 35 page than hardly anyone look at the 35 page and nobody know what's kind of important within your firm. And as you can imagine, that kind of decision to change the onboarding paperwork for your firm, that kind of decision really only happens if you're doing it intentionally. Otherwise, it just stays the same. Nobody ever kind of rethinks, like, should we be doing this better? And so the idea of continuous improvement is a real key to QM or quality management. And quality management used to be called quality control, but that was more associated with someone looking over the man on the factory floor's shoulder. And quality management is much more about kind of making a better factory floor generally, and not so much looking over his shoulder, but making the process better. And in terms of architecture, it was very much about the senior architect looking over the shoulder of the junior architect, because the senior architect could see all the work right there on the drawing board. But now that we're doing things digitally, it's a little less likely and a little less possible for the senior architect to look over the shoulder of the junior architect while the junior architect is typing away at the computer. So it's about continuous improvement. It's about elimination of waste in process. From now on, I'm not going to talk about it. Quality management is a wide field that applies in large part to manufacturing, but it applies to professional services like architecture too. And I'm going to talk about it from now on, just primarily, in terms of how it applies to architects. All right. So what are we talking about? Well, we're talking about, when we talk about quality management, we're talking about a customer-centered approach generally. And really, we're pretty broad in who we define as the customers. The customers, all the stakeholders, especially the stakeholders external to our firm. So it's not just the client, but it's also the contractor, it's our subconsultants, people like structural engineers or MEP engineers. And we're kind of putting ourselves in an intentional way, we're putting ourselves in the position of the client and saying, okay, what works best for them? How does it look to them? Is this contract have more than it needs to have? And does this contract, are we taking too long to sign the contract on our end? I'll give you an example from the Amber book. We have, as most of you know, we have a book that comes with, our Amber book's not really a book, it's a series of videos, it's a course. But there is a book that comes with the Amber book, but it's not really the book, that's the course. And probably, a third or something of our enrollees are people who have enrolled before, so they already have a book. Plus, when you sign up, we've just asked you for your address because we've had you pay, and when you pay, you have to put your address in for the credit card billing address. And so we don't want to start right after that by asking for your address again, because as far as you know, we just asked you for your address twice, and that's really annoying. In reality, the reason we need to ask for your address twice is we don't save it the first time because it's a third-party software that's actually going to collect your credit card information, because you don't want us keeping your credit card information. You want people who do that all the time and can provide the security and the kind of following the rules that need to happen when you're collecting credit card information. So from the point of view of the enrollee, we don't want to send them a book they don't need, but we don't mind doing that if we need to, but we don't want to ask them a question we just asked them, even though we didn't just ask them. So this is a kind of a quality management question, just from the point of view of the customer. What does this look like? And we're going to have, as part of quality management, we're going to have regular audits. And because it's primarily about customer facing, it's not really so much about assessing risk. Now, does that mean that if you Google a risk assessment in quality management, you won't get like hundreds of millions of hits? You probably will. In fact, I did it this morning and there were lots of hits, including all kinds of academic papers on risk assessment and quality management. But it's not that it can't happen, it's just that in the context of an architecture firm, if you want to be client-centered, you want to be excellent, which is a way to mitigate risk. If you're really good at your job and you're making sure that things that go out of the office are of high quality, but it's not really just about risk assessment. That's more kind of covering your own ass internally. And this is as an aside. Well, actually, before we do that, I'm going to give you another problem to do, and let's go ahead and do that now. Oops. This one. Which of the following is associated with an architecture firm quality management strategy? Same question as before. Select 4 of the 6. So go ahead and select 4 of those 6. So in this case, we said, which of the following is associated with quality management? And the answer is ISO 9001, lean systems, project audits, we're going to audit everything, and 6 Sigma. And we're going to leave off ASTM 9, and we're going to leave off separate quality management into its own department. And this is probably a good time to talk about these check all that apply questions, because they are by far the worst. I mean, on 3 different dimensions, they are the worst questions of the different questions that are question types that are available, and they are really common on the practice management exam in particular. And the reason they're common on the practice management exam is because, well, part of it is because practice management's fairly new, and they have this as this isn't a new one though, they've actually had this type of question for a while, so that's not why. But it's because what happens is, NCARB's original sin is that they use volunteer test makers. And volunteer test makers are fine. If you guys are good at these tests, I want you to become a volunteer, because we need better questions always. But if you have a volunteer test maker and they're asked to talk about something as commonsensical as quality improvement, what they're going to do is they're going to skim the Architect's Handbook for Professional Practice, and they're going to say, oh, here's a list of 4 things. And then I'm going to add 2 other what are called distractors in the test making world. And in the check all that apply, it's always going to be check 2, check 3, or check 4. They'll always tell you of the 6. And so maybe they'll have these 4: prevention costs, appraisal costs, internal failure costs, and external failure costs. And then they'll add something like they call it assessment costs and execution costs. You know, things that sound reasonable but maybe are not. Now, in reality, you could have read this and really understood quality management and quality improvement, but still gotten that question wrong pretty easily. And likewise, you could have not understood anything about it and gotten that question right pretty easily. So it's a bogus type of question, and it's the type of question that people who don't know how to ask a multiple choice or computer graded question are going to ask when it's difficult to make that kind of question. So especially if they don't have experience making test questions. So when you see something like we saw at the beginning, where assess risk seems reasonable, and track employee time in smaller increments seems reasonable, you might be tempted to check those. And if you do, don't worry about it. And the reason I don't want you to worry about it is because this particular type of question, these select all that apply in NCARB software, if you get 3 of them right but get the 4th one wrong, you get the whole question wrong. And so I don't want you to spend a lot of time on these questions, because even if you know the material, it's usually kind of a crappy question. Almost always, I would say, of every 10 bad questions that I've seen on ARE 5.0, 8 of them are a select all that apply. If NCARB could do one thing besides get professional people to write the test, experts to write the test, it would be to get rid of this particular test question, because it encourages people to make test questions that really aren't testing your knowledge of the material. Anyhow, likewise, if we go to this one, ASTM 9 is kind of like ISO 9001, but there are two different types of standards. One's the ASTM is, I think, American Society of Testing Materials, and ISO is International Standards Organization, and this one is a standard for, ISO 9001 is a standard for quality management, and ASTM 9 is not. Separate quality management into its own department. Now, in fact, there are lots of, quality management departments, especially in big firms. So it's not, maybe a better way to say it, the way they'd say it on the test is they would say always separate quality management into its own department. Because in general, you want to integrate ideas of quality management all the way across. So let's talk about some of these. That we haven't yet talked about. So we have, back to our first question, we have eliminate waste in progress. That's a big part of quality management. And waste could mean, do we really need that third drawing set? But it could mean just kind of thinking about how many site visits do we need and coming up with a process and say, okay, if we have a project that's more than 45 minutes away and it's less than $1 million, we're going to limit it to 3 site visits. And if it's, unless we need to for some specific reason. And if it's less than 45 minutes away, but it's between $1 and $5 million, we're going to limit it to 5 site visits, and that kind of thing. So we're kind of saying, okay, we're making easy checklists, and we're using that to eliminate waste. It could mean that we're just taking too damn long to turn around RFIs. Now, for those of you who have not worked in an office or haven't worked in an office very long, an RFI is a request for information. So, of course, the contract documents go out to bid, and then the contractors bid on the documents and they get the contract, and now they have to build the building exactly as it's stated in the documents. And there are going to be places where they just can't figure out how to do it. There's something about your drawings that's incomplete, there's something about your drawings that's unclear, or maybe they're just trying to cover their own butt in case they do something wrong, because they think they know how to do it, but they want you to be part of the decision-making process, so that if there's a leak later, they can say it was you making a decision in the office and not them making a decision in the field. So they will send a request for information, and we should have a little contest to see what's the most, why don't you guys in the chat let me know what's the most request for information any project in your office has ever gotten, if you happen to know. But there sometimes can be hundreds of requests for information, possibly even more than 1,000, I would suppose, and for a really big project. And so, architects are notoriously slow at turning those things around, and that's a huge problem for the contractor and the owner in terms of keeping on schedule. So if it's the case where the architect, if you have a quality management program, you recognize that the customer is the contractor and the client, that a big problem is that you're taking too long to turn around RFIs, and then you start digging in to your RFI process, and you start thinking, okay, we have a lot of paperwork internal in the RFI, kind of cover our own butts paperwork to show that we did the research that was indicated for the RFI. But you could say, well, yeah, but the risk management point of view, the risk we've avoided by documenting every move we made on the RFI, when we obviously didn't document every move we made anywhere else, really maybe that's not a good way to do risk management. Maybe we could eliminate some of our risk in terms of liability, in terms of disputes in the future, but we still have a pretty good paper trail. We have the original drawing, we have the RFI, we have our response to the RFI. Let's eliminate all the internal paperwork, so when an RFI comes in, an RFI response can go back out without any internal paperwork, which is insane for some firms. But we're going to go ahead and do that because we think we can take the average 10 days that we're taking to turn around an RFI, and we think we can drop it down on average for 80% of our RFIs, the simplest 80% we think we can turn around in less than 48 hours. And that will be huge from the point of view of the customers. And so that's the kind of waste we want to eliminate. And then we want to utilize scorecards. And scorecards are just another way to assess things. And just because something is a scorecard and given a number does not mean it can't be subjective. So we can give a scorecard based on things like client satisfaction. We can give a scorecard based on things like the intellectual property you've developed on that project. So it could be that project was your first indoor swimming pool, and as such you did a bunch of research, and now your firm has a bunch of details in their library for how to do enclosure on an indoor swimming pool in a cold climate. And that's good to have, and that has some value even if it's hard to measure. So just because something is hard to measure doesn't mean it gets 0 points. If someone's a good team player, you don't have to prove they're a good team player. If you know they're a good team player, put it on their scorecard and use that to help eliminate waste. And by waste, I'm including employees or positions. It could mean that you need to lay off some people, or it could mean that you need to fire a couple of less effective people who are not giving value. So it's really all about the value. Now, there are 3 recognized and long established they're not all standards, but they're programs. We'll call them programs that centered around quality management, and all of them have certain things in common. They're all very customer focused. They all involve continuous improvement. That's kind of a hallmark of any quality management program. And all 3 pretty much take really common sense ideas and make them intentional. And they're all implemented firm-wide, and we'll go through them. The first we're going to cover is Six Sigma. And Six Sigma is not quite as applicable to architecture firms as it is to manufacturing firms, but it basically is all about eliminating variation. So we want to standardize the results. Now, there's lots of reasons we don't want to standardize results in architecture. The site may be different, the climate may be different, but maybe if we're doing the architecture of the buildings that house the power supply for a cell tower, maybe then we can start to standardize things and eliminate variation. Six Sigma can be third-party verified, but it's not usually. And that brings us to ISO 9001. ISO 9001 is a very formal standard. It takes like anywhere from 6 months to about 3 years to get the official certification. A third party you hire will say, okay, you are now meet the requirements of ISO 9001. And it's more for large firms, especially large firms that have multiple offices. So if you have your Baltimore office and your LA headquarters and your Seattle office and your Denver office and so forth, and you want to make sure that there's a kind of a quality management across all the firms, where maybe some of the firms in the hinterlands are a bit removed from the pressures of corporate, you can use ISO 9001 as a vehicle perhaps for that. And it's a way, we're going to measure teamwork and leadership and purpose and decision making and consistency and communication, and we're going to do it all through a lens where we're looking for mutually beneficial relationships, where I can win, the client can win, the contractor can win, everyone's happy when they leave. And then that brings us to the third program, which is a little bit less formal, but it's also very established. It's just more of a philosophy than it is it's not like LEED, where you get a piece of paper saying you're lean. There's no one who issues that. Lean systems is kind of an interesting history. The Japanese in the 70s and 60s were known to make really low quality cars. But back as far back as the 1930s, an executive at Toyota had visited America and seen the way things work in grocery stores in America. And they're pretty efficient in grocery stores in America, even compared to Japan, where I used to live when I was in high school, where the stores were, at least at the time, much smaller. And it's pretty amazing that there's all these different products and the customer can just grab them, and they're pretty logically ordered. And so the Toyota executive saw that and brought it back to Japan and said, we're going to do our entire assembly line like that, where there's really standard products, and we're going to make it really easy for people to get the parts that are going to go on. And what happened was Toyota especially, but the Japanese car makers in generally shed their reputation for having low quality. And in the 80s, they kind of established a reputation for having higher quality cars and cars less likely to break down, than American-made cars, which was kind of a sea change because up until that point, American cars were seen as very high quality and Japanese were considered generally to be low quality. And one of the things that Lean Systems does, as you might imagine from its name, is it's pretty focused on eliminating waste. In fact, I think I remember reading, I can't find this when I looked for it online, but I remember reading in the 90s that 1 year Toyota had taken the Camry, and instead of adding new parts, they focused on just eliminating parts that weren't necessary, and they eliminated 1,100 parts, as I remember it. So maybe there were 6 bolts that kept the engine block down, and they were like, let's try it with 4. 2 less bolts that can break or need to be replaced later, and we can make the car lighter, and we can make it cheaper to make because we have 2 fewer bolts. So that's what Lean Systems is all about. It's eliminating waste. And in the case of architecture, we're eliminating waste in the firm's processes. Do we really need that 3rd visit to the site? Do we really need that 3rd copy of the drawing set? Do we really need 10 days to turn around an RFI and so forth? All right. That brings us to next week's question. That concludes the question from this week. So this is for next week. You can go ahead and focus on this. You can join us on Thursday of next week. A bidder wants to better understand the type of soil on the site. Why can't a bidder call the architect to get a clarification? A bidder wants to better understand the type of soil on the site. Why can't a bidder call the architect to get a clarification? And then we're at the point where we're going to look over the question that we got on the chat from last week's 40 minutes of competence. And the question is there a huge difference where this bracing is placed, center or ends on the grid? So we talked about where cross bracing or lateral bracing from X's and K bracing and V bracing and chevron bracing and K bracing and cross bracing and single diagonal bracing and shear walls. Where those go, and they generally have to go in one bay, but they don't have to be on one end or the other or the middle. They're often on one end or the other because often the middle has something like a door or a big window or a balcony or something that's going to protrude, and if we're going to have some kind of bracing that goes across the middle of it, it may be hard to get that door in. So often it's going to be on one side or the other of the middle, but it doesn't have to be. There's no structural reason I know of that it should be on the middle or the ends. It really doesn't matter.
Cost estimating techniques.
Mm-hmm.
Coming that architects usually do this at the beginning of the project, or recurring every stage of the project, but not during construction documents, right? So just with experience, I've seen drawings that are in construction documents, and there's some cost estimating questions, and it's just tricky in that sense, but more so as cost estimating techniques that architects could use.
Are you talking about for the exam or for their career or for both?
I don't want to give too much out there, but it's stuff that I've perceived from testing before.
So you think that cost estimating in your experience has been an important element of the test?
Yeah,
I think you're allowed to say that. That's not giving anything away. Just
okay.
Saying that you can focus on that. My understanding is that's fine. We can talk in broad strokes like that.
Okay.
Yeah, I certainly can cover this. I've actually covered it in a previous 40 minutes of competence, but I'm happy to talk about it again. For cost estimating, and there's 2 different answers, but there kind of has some overlap for the exam and for your profession. For cost estimating, when in doubt, the more common, if you look at construction sites, the more common solution is going to be the less expensive. And the less processed solution is often going to be the least expensive. And the less bespoke or customized, it's going to be less expensive. Let me explain what I mean. If you look at the next house under construction you go by, if you look at the skin of if you look at the sheathing, it's typically going to be plywood or OSB. What do you think in terms of your experience? Is it usually plywood or OSB? I'll go ahead and answer that. It's almost always OSB. And so if you were given a question about the relative cost of plywood and OSB, you can almost always assume the one you've seen more often is the less expensive one. So if you see OSB more than plywood, you can bet that it's OSB. Likewise, OSB, as you might imagine, doesn't require big sheets of wood, long plies that are kind of spun with a log. It's more like a bunch of chips that are glued together. And you can imagine a chip is a lot cheaper. It's a waste product of a lot of other milling. A chip is a lot easier to glue together than taking a log, which is called a flitch, and then taking it on both ends like a corn on the cob, and then spinning it, and then taking a blade and shaving a veneer off of it. That's a pretty expensive process. So it's a much easier process. So you know that OSB is less expensive. You know that steel is going to be less expensive than stainless steel because you see more steel, and because stainless steel requires all kinds of alloys and shiny and make them more rust resistant, and so it requires nickel and all these other things to be added to it. You know that if you have a module of 4 feet by 8 feet for plywood and OSB, and 8 inches by 16 inches for concrete block for CMU, you know that if you don't have to cut the CMU, if you can make the face of the concrete block some multiple of 16 inches, then you have to cut fewer blocks because you can have whole blocks on both ends, or at least on one end, and probably on both ends. So you want to have dimensions that are multiples of 16 inches in length and 8 inches in height for your concrete block walls. Likewise for brick. The fewer corners, then the more economically you can build a building. So every time there's a corner, especially if it's in masonry, but anyway, anytime there's a corner in plan or section or a balcony or anything like that, it's going to cost more money. Likewise, let me think of some other examples. You see membrane roofs more often than fluid applied roofs in low slope roofing. You see particle board or MDF more commonly than solid wood in furniture. All of these kind of things that are more common are almost always less expensive. And a big one for concrete is formwork. So formwork is like hugely variable when it comes to concrete construction. And so if you can have either modularized formwork that can move around, or modularized formwork that can be reused and move up the building as the forms are being poured, that's a huge savings because formwork is wildly expensive. It's said that in concrete construction, you build the building twice. Once at a formwork, we actually have to hire typically a structural engineer to engineer the formwork for the concrete, and then the engineer also has to engineer the concrete itself.
And then I've also heard that the wood and the amount of wood is also mainly a big part of the cost.
Yeah, no, it's the wood and the concrete is not an inexpensive activity. What else? If you thinking of some other kind of common cost questions. For foundations, if you can avoid the water table, in other words, if you can not go deep, well, if you can stay shallow, you can make the foundation much less expensive. And if you avoid being up against adjacent to kind of butting up against other buildings, that becomes very expensive. But the big one for foundations, besides not going too deep, and this related to not going too deep, is to stay dry. So if your foundation is above the water table, it's way less expensive than if your foundation is below the water table, and every time, all day, every day, you have to be pumping water and mud out of the giant pit you've dug in the ground. So these are some of the most common kind of broad stroke ideas for any kind of cost question. I actually, in my experience, and maybe your experience was different, but in my experience with ARE 5.0, I don't think it's valuable, particularly valuable for you to memorize costs. I don't think that's necessary. I think it's much more about understanding these principles. And in my experience, even if there are a lot of questions we're not talking about enough to justify memorizing, because it's so unlikely that you would memorize the right table. So if you're looking at, if you're looking at a table of porcelain tile versus other type of ceramic tile, I can't imagine that that would be the kind of thing that would be useful for the exam, or really even for your career, because you can just Google that stuff. However, if you're talking about vinyl molding versus on the vinyl baseboard molding versus wood baseboard molding, well, you know that crappy cheap buildings have vinyl baseboard molding, so that's obviously going to be less expensive. So whatever you see the most of is almost always less expensive, and whatever requires the least amount of labor is almost always least expensive. Any other questions?
No, that's for now. But thank you very much. This is great. Those broad strokes. If I take a nugget of information on this, is to revisit really construction methods and building materials, and get a better understanding of that.
Yeah, I mean, it's a really important part of it. It's one of the few parts on the test that requires a lot of knowledge, but it's still worth going through. Like, structures requires a lot of knowledge, but it's probably not worth going through because there's not that many questions on the exam. But there's a lot of knowledge required for materials and methods of construction, and it just so happens that there are a lot of questions on, depending on your on which exam you're taking, but there's a lot of questions on both systems and materials and methods of construction, so it's worth
Right.
going that route.
Right. Thank you, Michael.